We are now going to talk a little bit about glacial landforms, and just a warning that there's really a lot of content here, and it's super interesting and super important for understanding everything around us in Alaska. You're going to have to spend some time looking at the lecture, then comparing it to the text, and then looking at the various maps that I have given for you to look at as well. So it's going to require you to sort of go back and forth to really become familiar with all the different types of glacial landforms that are out there. But let's go ahead and launch in a little bit. And we are going to start off talking about all the many types of landscapes that we see in South Central Alaska. Not just the things that we see in the mountains, but also many of the valley areas as well have been shaped by glaciers. Here's an old surficial geology map that will be available for you in Blackboard that shows landforms in and around the Anchorage Bowl. And you will learn that there are glacial landscapes stretching all the way from the tip of Kincaid into the Chugach Mountains, and from Elmendorf Air Force Base all the way down to very South Anchorage. And this is the case not just for Anchorage, but for many other parts of South Central Alaska. We live and play in glacial landforms in Alaska, which is pretty fun, actually. The key erosional landforms include a whole bunch of different landforms that are essentially caused by glaciers plucking and coring and shaping valley-like forms that then impact the shape of mountains, and then also leaving behind cool little landforms that are a product of material that they deposit and the erosion itself. This first image is a little visualization of an area that is far up Eagle River. It's called Camp Creek. And it shows quite clearly the distinction between a glacially formed valley, which is U-shaped in nature, because a large valley glacier poured out of the mountains here and essentially sculpted this huge area, versus the V-shaped valley from the creek that was created after the glacier retreated and water flowed down through this area. That V versus a U shape is indicative of a glacial area. We're going to look at a bunch of different types of features now, but I actually want to show these features to you on a picture, and then we'll take a look at a couple maps and see which of them we can identify. This diagram right here shows what a landform looks like pre-glacial. It's then filled by glaciers, and the glaciers erode and pluck, creating U-shaped valleys, as well as other features up in the mountains. And then, when the glaciers retreat, these are the landforms that are left behind. Arêtes, which are steep ridges between small glacial valleys. Cirques, which are the bowl-like valleys formed by glaciers. Hanging valleys of small glaciers that are tributaries to major ones. Mountains that are sculpted by glaciers eroding to all sides of them, forming horns. Small little lakes left behind by glacial deposition and erosion, which are called paternoster lakes. So these are all the sorts of things that we can see when we look at a glacial landform. So let's actually look at a glacial landform right now, or glacial landscape right now, by first looking at an area very close. This is the Ship Creek Valley right through here, and this is the South Fork of Eagle River. And all around this area are large numbers of glacial features. Most of the large valleys are U-shaped valleys. In the case of Ship Creek, there's a V-shaped valley at the very end of it, but if you look at the very top of it, you'll see that the contour lines are very spread apart, indicating a valley glacier had been there and has now left behind a U-shaped valley. Many of the peaks, like Cantata Peak and Eagle Peak, are great examples of mountain horns. And the smaller glaciers, or the remnants of where small glaciers were, are a great example of cirques, including the small lakes that fill them in, which are called tarns. We also have many ridges that separate different glacial valleys, which are called arêtes. If we take a look over in this area of the Willowa Lakes right through here, and let me get a little bit closer to it, you'll see that there are a series of small little lakes that march up the valley. This is an example of Paternoster Lakes, as they're called. So just here, very close to Anchorage, there are all sorts of different glacial features. And if we go to the north into the Talkeetna Mountains, we'll find the same thing. This is the general Hatcher Pass area. It's actually a little bit past the Hatcher Pass area to the east where the Kashwitna River is. But if we scroll down below here, this is where Hatcher Pass sort of starts, where the horseshoe turn is right here. All these lakes are great examples of tarns that sit in cirques. The valleys are, many of them, U-shaped. We also have a couple little Paternoster lakes that are found up in here as well. And most of the peaks are great examples of horns with ridges formed as arêtes around them. So there's really all sorts of great glacial stuff here. If we go on to this map that shows an area to the north of Seward and Kenai Lake, we'll see that one of the really key features that is closely related to glacial erosion are large sort of stretched out lakes like Kenai Lake or Crescent Lake are. These are valleys that were formed by glaciers that are then flooded later on to form these large linear lakes. If they're connected to the ocean, then they are called fjords. Going up a little bit further to the north and a little bit more to the east is an area of the Taslina Glacier, where again we can see all sorts of landforms being created. Taslina Glacier itself, if it retreats, will form a broad U-shaped valley in it. But there are other U-shaped valleys that are around it that will become hanging valleys later if and when that glacier does retreat. We can see tarns, we can see horns, we can see Paternoster lakes in here as well. So these are all great examples of glacial erosion. Now let's go back to the PowerPoint. Here's a great example of a fjord. This is Yosemite Valley, which is a wonderful example of a U-shaped valley with a hanging valley in it. That's Bridal Veil Falls that comes out of that. It's really breathtakingly beautiful. I recommend people visit there, even if they're used to beautiful Alaska landscapes. The depositional landforms are a lot more complicated than the erosional ones are. And again, you're going to have to spend some time reading about them in the text to fully appreciate them and understand them, and then look at the map examples that I've given you to see if you can identify them. Depositional landforms of glaciers can essentially be broken into two basic types: the till features and then the drift features. The till features are created essentially when large amounts of glacial junk is just left behind. You've probably seen till features in glacial moraines, which are the large areas in front of a glacier where there's a huge amount of debris, or the strips of black that run down the middle of glaciers or along the sides of glaciers. Those are all examples of types of till. Great big huge rocks that are left behind, which are called glacial erratics, are another example of this. And it's very easy to find till plains because oftentimes they have really deranged drainages in them with lots of little lakes and swamps, which are often referred to as kettles. When we find drifted features, those drifted features tend to be much more organized. Oftentimes they're as outwash plains, which is essentially the braided river that came out in front of a glacier when it sat in one location for a while, that often forms a relatively flat surface. Sometimes those flat surfaces then have other features that are on top of them that often look like till features and sometimes are till features, but often are features that have water involved in them, called glaciofluvial features. This includes little kettles sometimes, but also lumpy hills called kames and sort of snake-like hills called eskers. I'll show you a picture of that later on. We can also sometimes see drifted lake and delta deposits in glacial areas. Kincaid Park, for example, has delta deposits in it. So even though it's very uneven, more like a till plain, it's actually made of drifted features. And then there's a special kind of feature that is associated with stratified drift, which are drumlins. These are sort of egg-shaped hills that often show up in large numbers or swarms in areas that were covered by very large glaciers. East Anchorage actually has a small swarm of drumlins, but there are some other examples, and I'll show you a picture of sort of one of the classic areas of drumlin swarms in the lower 48. In addition to till and drift, glaciers also involved wind deposition because they produce a lot of small particles in addition to big particles that can be picked up by the wind, transported someplace, and then deposited later. And when that happens, it produces features that are referred to as loess features, and I'll show some examples of these. Let's again look at sort of a couple pictures of this and textbook pictures, and then we'll look at a few maps. So this is just glacial till and garbage. It's morainal stuff that is found piled up along the sides of a glacier, and in fact on top of a glacier as well. This diagram right here shows a glacier in retreat, and it makes a distinction between the area that was in front, where we had braided rivers and it formed a large outwash plain, and then the till that was left behind that. Now, obviously, things get mixed up, and sometimes till and drift start to sort of combine with one another in different ways, like the formation of kettles is a good example of that. This picture right here shows the area that we're going to be going to in upstate New York or very close to it. You can see these egg-shaped hills all through here. These are drumlins found in this area. All right, the first map I want to show to you is actually a map that I just recommend you spend some time taking a look at, downloading and looking at. It's different from the other maps that I have shared with you so far. It's an old USGS surficial geology map of the Anchorage area, and it shows all the different features that are found in and around the Anchorage area. It uses a special symbol for drumlins, which are a line with a little circle drawn in it. Many of these areas represent different colors that show different types of features. For example, this sort of pale orangish color represents a drifted area or outwash plain, the flat areas that we find in Spenard and downtown Anchorage and Elmendorf Air Force Base. And then we also find to the north of Elmendorf morainal deposits. We find morainal deposits along the hillside, and then an interesting mix of till and outwash found in many parts of South Anchorage. Kincaid has a special type of delta deposits. So take a look at that map and just sort of pick out, if you're in the Anchorage area, which type of features you have in your area. But let us briefly look at a couple of maps. The first map is one we've already looked at, so I'm not going to spend a bunch of time on it, but this is the McKinley bar map. And you can see the Muldrow Glacier back here. Imagine that Muldrow Glacier and neighboring glaciers spilled out over this vast area here. As those glaciers retreated, they left behind two types of deposits. Oftentimes they left behind outwash in the form of braided rivers, as the McKinley bar is being created right now. That will be an outwash plain. But some of these areas that have all the deranged drainage in them, little lakes and things like that, probably are composed more of till materials, probably a combination of moraine and other types of till that are left behind by the glaciers. So we can actually see this stuff actively being created in the Anchorage area. Many parts of the United States, this sort of glacial stuff happened quite a long time ago. For example, here's a map from Plimpton, Massachusetts, And you can see that this area was definitely some sort of a till plain. Lots of deranged drainages with little lakes and little swamps, small little lumpy hills that are left by the glacier as it retreats behind it. Palmyra, New York is a great example of a place which has swarms of drumlins, and you can see that there are dozens of these egg-shaped drumlins that are spread all over this area right here. And you'll notice that they've got this sort of very linear look to them. They have an axis, usually in the direction that the glacier retreated, and they're sort of, like I said, egg-shaped, relatively flat on the top with steep sides around them. On the UAA campus, the hill that is just to the east of the arts building that APU sort of sits on top of is a great example of the drumlin. But there are a number of other drumlins all around the Anchorage area. So going back to the lecture material here, I've got one other image of a type of deposit to show you. It's called an esker. An esker is created in a stratified drift environment when you essentially have a glacier sitting in an area, leaving behind braided river outwash, as you can see here in this special imagery of Bird Valley that shows very fine topographic details. But you'll see up to the north of the map is a sort of snake-like feature. That's an esker. It was created by a river that flowed in a glacier, sort of underneath a glacier, and it deposited material, but instead of eroding down into the outwash, it left it above the outwash and created this sort of meandering river that was revealed later on when the glacier retreated. Bird Valley has other glacial features in it as well, morainal material down here and along the sides of the valley as well. Great example, though, of outwash material being left all throughout this area, both by a historic river as well as by Penguin Creek, which is creating a small outwash plain over here. This map is an orienteering map, and I think I mentioned in my introductory materials that I love the sport of orienteering. This was made by a friend who processed a bunch of interesting data from the Matsu Valley near the Willow area to create this map that shows, again, an area of glacial till with lots of little lakes. These yellow areas are probably swampy areas with little hills and depressions all around this area. I just wanted to sort of show you another visualization of the same type of thing, but this is a very fine scale topographic map, much finer details than what we see on these other maps. And then the final thing to show you are just some examples of glacial loess. Loess is created when the wind deposits very fine, usually silty particles of glacial material. It's very interesting material in that it, when it erodes, it forms very steep slopes, as we can see by these loess areas found in China that actually villages are built into. This is a picture down here on the lower right-hand side of the Loess Hills in Kansas. And then I believe this picture on the lower left is of Bodenberg Butte, which itself is covered with large amounts of glacial loess. So looking at all of these things sort of begs the question, when did all this stuff get created, especially in places that are very far from glaciers right now? And this will extend a little bit into the next lecture when we talk about permafrost, because the location of permafrost is often very closely related to where ice covered the planet in the past during the ice ages, or the geologic period which is known as the Pleistocene. The Pleistocene took place from about 2.6 million years ago until just really 12,000 years ago. It has involved a number of epochs where ice has grown and covered large portions of both North America and Europe and Eurasia as well, as you can see right here. When those large continental ice sheets covered these parts of the world, we ended up with a much wider distribution of glacial features than we have today. It also impacted sea levels as well, which is important actually for understanding human history and migration, but also explains things like large lake beds that are found in different parts of glaciated areas, and different types of features that, of course, are now found very far away from where glaciers live today. So that's all I know. This lecture was a little bit longer, but it's really important stuff, especially if you live in South Central Alaska and you see this stuff all the time. I encourage you to go back over this material, look at it closely in the text, and break those maps out and take the time to look at those maps and see what sort of features you can find. The last of the geomorphological lectures will be next, and that is permafrost.